Hello and welcome back. Today, we'll be talking about the cross product. Now, in the last video, I talked about how you could multiply a vector by another vector and end up with a scalar. This is the dot product. Now, I'm going to show you a different way of multiplying vectors. And this time, when you multiply them, you get a vector as the product. This is called the cross product. Notice the different signs I'm using. So, how is the cross product different from the dot product? Well, for the cross product, we're going to be multiplying the magnitude of the first vector by the component of the other vector that is perpendicular to the first vector. Let me show you what this looks like. The section that I labeled b sine theta is the component of vector b that is perpendicular to the vector a. Like I said earlier, the cross product is multiplying the magnitude of the first vector by the magnitude of the component of the second vector that is perpendicular to the first vector. So, the cross product is equal to a b sine theta. Now, that might look correct, but we need to make a small change. AB sine theta is not exactly the cross product. It's actually the magnitude of the cross product. Like I said, the cross product gives us a vector as the product. So it wouldn't make sense for AB sine theta to be the product, because this gives us a scalar. So A cross B magnitude is AB sine theta. A and B both reference the magnitude of the vectors, and theta is referencing the angle in between the two vectors. Now, you may be asking, if the cross product is a vector, which way does it point? Vectors must have a magnitude and a direction. So what is the direction? Well, it turns out that the cross product is always perpendicular to the plane that holds the two vectors that you're multiplying. So, if A and B are on the xy plane, the cross product vector must be perpendicular to those two vectors. Now, this is a little confusing because how can you make a vector that is perpendicular to both A and B? And the answer to that is that we have to work with a new axis. Let's say that A and B are on the xy axis. The cross product of those two vectors is going to end up being on the z-axis. Now, which way does the z-axis point? Well, it points into and out of the page. So, if you're looking at the screen right now, the cross product of A and B, if they're on the xy plane, is going to be either towards you or into the screen. This might seem a little confusing at first, but we're going to be using this concept a lot, and you'll definitely get the hang of it. Now, how do we find out if it goes into or out of the page? For that, we have something called the right-hand rule. Now, if you'll excuse my terrible drawing, you'll recognize this as a right hand. Now, the right-hand rule states that if you point your index finger in the direction of A and your middle finger in the direction of B, your thumb will naturally point in the direction of A cross B. And that will either be into or out of the page, given that A and B are on the xy axis. This sounds kind of arbitrary, but it does work every single time, as long as you're using your right hand. I want to mention really quick that the cross product is not commutative. Now let's think about why this may be. If we point our index finger towards the first vector and our middle finger towards the second vector, we'll inevitably point our thumb into or out of the page. Now, let's say you're doing the opposite cross product, the first instance being A cross B, and the second instance being B cross A. Well, your thumb will be pointing in the opposite direction, which means it'll be the opposite of the first cross product. So there is no way that the cross product can be commutative. However, this property does give us a nice equation that A cross B is equal to the negative of B cross A. Now that we have extended past the xy plane, we need to make a new standard basis vector. So far, we've had I and j. But now we have a third dimension, and that standard basis vector is called k. Let me draw it out for you. Perhaps this makes it a little easier to conceptualize a vector coming into or out of the page. That k vector is what I mean. And of course, they are standard basis vectors, so the magnitude of all three of these are going to be equal to 1. Now, how do we compute the actual cross product? Let's say we have vector A, which is x1, y1, and z1. And vector B has x2, y2, and z2. A cross B is going to be this determinant. As you can see, the first row are the standard basis vectors, the second row are the components of vector A, and the third row are the components of vector B. Now, if you're unsure what a determinant is, that's something that you should definitely research because it's going to come in very handy in the future. However, I will supply an equation to use for the moment. As you can see, this equation gives us an I, a j, and a k multiple vector. This is our cross product. I know this equation looks a little scary, but once you learn what a determinant actually is, it'll become much easier to understand. And hopefully you'll learn that in some math class like linear algebra. Let's do an example. Let's say vector A is 1, 2, 3, and vector B is 2, 3, 4. A cross B will be this determinant. Now, I'm not going to go in detail on how I actually calculate this determinant because that's something you have to learn in a math class. So for now, I'll be just writing the answer. And hopefully you can follow along and check your answer. And I got -1, 2, -1 as my final answer. Thank you for watching, and I hope this was informative. Happy learning!